DFS Memorials, affordable cremations nationwide.
Today, we're going to talk about a supply chain. And usually, when we say that word, you're thinking about microchips or maybe how coffee gets to your kitchen.
Right.
But today, we're looking at a supply chain that, well, it exists almost entirely in the shadows. It's a system that handles something that happens every single day to thousands of people, but almost none of us know how it actually works.
It's the one logistics network that eventually claims 100% of the population.
Exactly. We're talking about the massive invisible shift in how society handles death. And I don't mean the grieving process or the funeral or the theology of it all. I mean the engineering.
The physics, the sheer logistics of it.
The sheer logistics of what we're calling the industrialization of finality.
And that title, it really feels appropriate. When you dig into these sources, we've got trade journals, engineering schematics, even zoning board minutes, you realize pretty quickly that we've moved past the era of the village undertaker. We're not talking about a quiet local service anymore. We are looking at a high-efficiency industrial sector.
And the numbers, they really back that up. I was honestly surprised by the sheer scale of the shift. It feels like it happened overnight.
It's a tipping point. I mean, look at the United States. Cremation rates have pushed past 50%. In the UK, it's closing in on 80%.
80. Wow.
And when you have that kind of volume, the old infrastructure, it just breaks. You just can't handle that level of demand with a single brick oven in the back of a family business.
So that's where we see the rise of what the industry calls the super crematory.
Right. These are facilities that are designed to manage hundreds of cases, and that is the industry term every single day. And our mission for this deep dive is to really look at the machinery that makes that possible.
We're parking the philosophy at the door.
Exactly. We're looking at thermal engineering, automation, and the regulatory frameworks.
Which is fascinating in its own right. But before we get to the burners and the robotics, we have to talk about the software, or the legal software, because the stakes here are terrifyingly high.
They are absolute. Think about burial for a second. If a mistake is made, a misidentification, or a question about the cause of death comes up 6 months later,
you can fix it.
You can exhume the body. It's traumatic, for sure, but it is reversible.
Cremation is the end of the line.
It is final. Once that process is complete, all biological evidence is gone. There's no DNA to test, no autopsy to perform. And because of that irreversibility, the industry operates under this massive legal fail-safe mechanism.
It kind of reminded me of nuclear launch protocols. You can't just turn the key.
That's not a bad analogy. It starts with what's called the chain of authorization. The industry is, terrified of litigation. So before a body even enters the facility, they need to establish the legally authorized person, the LAP.
And this isn't just whoever shows up with a credit card, right?
No, not at all. And this is where it can get messy for families. It's a strict legal hierarchy. If the decedent left written instructions, that's gold. But if not, it goes to the spouse, then the adult children, then parents.
I can just imagine the friction. If you have 3 siblings and 2 want cremation and 1 wants burial,
the crematorium will just hit the brakes immediately. They need total consensus, or at least a signature from the highest-ranking person that indemnifies them. They cannot risk a lawsuit.
There's also this layer of medical scrutiny that I found really interesting.
The UK is very, very rigorous here. In the US, you generally just need a death certificate signed by a doctor. But in the UK, a separate medical referee has to review the case specifically for cremation.
And their whole job is to just second-guess the cause of death.
In a way, yeah. Their job is to ask, is the cause of death definitely ascertained? Is there any chance this was foul play? Because once that button is pushed,
the evidence is gone forever.
Precisely. That's also why you see mandatory waiting periods. Most places require a 24 to 48-hour buffer. It's a logistical pause, a last chance for a legal objection or a police hold.
Okay, so assuming all the paperwork clears, you then have to actually do it. And this brings us to the geography, because nobody wants a super crematory next door.
Oh, the NMB Y factor, not in my backyard, is a massive constraint. You see these vicious zoning battles. Connecticut, for instance, has these strict buffer zones. You can't be within 500 feet of a residence.
And this is where it gets into that functional equivalence concept, right? I saw this in a New York case.
This is a key insight. A town wanted to ban a pet crematory. But the court looked at the engineering and said, crematory is a crematory.
Whether it's a person or a pet.
The machine is functionally the same. It's an industrial gas-fired incinerator. The physics doesn't care about the passenger. So the legal precedent is if you ban one, you have to ban the other.
It's legally classified as heavy industry.
Which brings us to the machine itself,
Yeah.
the retort.
I think most people, myself included, probably picture a stone oven, maybe a heavy iron door, like a big pizza oven, frankly.
It's so much closer to a jet engine. The technical classification is a Typhi incinerator. And the biggest misconception is that it's just one big chamber with a fire in it.
It's a two-stage process.
Exactly. Stage 1 is the primary chamber. That's where the body is placed, usually in a combustible container. And this chamber has these high-velocity burners. We're talking millions of BTUs.
And the design has to deal with a grim reality, which is that the human body is mostly water.
It is. And fluids are a nightmare for this kind of engineering. So modern machines use what's called a hot hearth design.
How does that work?
The floor is heated from below, or it's designed to hold a massive amount of heat. The goal is that any fluid hitting it just evaporates instantly. It flash boils, it prevents pooling, and speeds up the whole cycle.
But that first burn, that has to create smoke, gases.
Yeah.
And you can't just vent that out the chimney.
Absolutely not. Illegal and a PR disaster. That is where the secondary chamber comes in. This is arguably more important than the first one. It's the pollution control center.
So all the smoke gets pulled into this second room.
Yep. All the smoke, the odors, the volatile organic compounds, they're pulled in there and they're hit with extreme heat. We're talking 1,600 to 2,000 degrees Fahrenheit.
Okay, and this is where the 3 T's come into play. The notes really emphasize this.
The 3 T's are the holy trinity of combustion engineering: temperature, time, and turbulence.
Let's break this down. Temperature is obvious.
Right. You need it hot enough to just obliterate the pollutants. Time means retention time. The gas has to stay in that superheated chamber for at least a second or two to ensure it's fully cooked.
And turbulence, what's that for?
That's the mixing. You need to violently mix the hot air and the unburned gases so every single molecule of smoke comes into contact with the flame and oxygen. It forces total oxidation.
So if it's all working right, what comes out of the stack is nothing.
Ideally, just invisible heat and carbon dioxide. Odorless.
Huh.
If you see black smoke from a crematorium, something has gone very wrong with one of the T's.
But that heat, 2,000 degrees, that must just destroy the equipment over time.
It is brutal on the materials. The inside is lined with refractory lining. It's a special high alumina fire brick. But think about the thermal shock. You heat it up, then you open the door and let in room temperature air.
It cracks.
It cracks and flakes off. It's a consumable part and a very expensive one. You're looking at $15,000 to $20,000 every few years just to reline the bricks.
Wow. And you mentioned operating. This isn't a guy with a shovel and a dial anymore, is it?
No, the days of the manual operator are long gone. We're in the age of the PLC, the programmable logic controller. Systems like the Matthews Empire. It's basically autopilot for fire.
So the operator just hits start.
Pretty much. They enter the weight of the deceased, the type of container, and the computer takes over. It watches oxygen sensors. If the fire gets too hot, it cuts the fuel. If oxygen drops, it opens the air dampers. It keeps the machine in that optimal operating window constantly.
And it's that automation that unlocks the speed, because we're seeing a huge jump in throughput.
It's a volume game now. An old brick retort might take 3, maybe 4 hours. A state-of-the-art machine can finish a cycle in 70 to 90 minutes.
That's incredibly fast.
And they are rated as Super Duty. That's the actual term. They're designed to run 24 hours a day without cooling down.
So a big facility with, say, 10 of these machines.
You're looking at 150 cremations a day. That is the super crematory. It's logistics on the scale of an Amazon fulfillment center.
Let's just walk through that cycle. The timeline is striking.
It's a staged event. First, preheating. You have to get that secondary chamber up to 1,600 degrees before you even open the door. That's about 20 minutes.
Okay, then you load the container.
Right. The first 20 minutes of the burn is mostly the container itself. Then you hit primary combustion for about 40 minutes. That's reducing the soft tissue. Then you have calcination.
That's the bone phase.
Yeah. This is where the organic material is gone, and the heat makes the bone fragments brittle. That's another 30 minutes or so. Then finally, cooling and processing.
I want to pause on the loading part, because opening the door of a 1,600-degree oven seems hazardous.
It is. You get something called flashback.
Which is?
A sudden rush of oxygen hitting that superheated environment. It can cause the container to ignite explosively. You can literally blow flames out the door.
Terrifying.
Which is why modern facilities use inline autoloaders. It's a conveyor system. It pushes the container into the retort in under 10 seconds. It keeps the operator safe from the radiant heat and gets the door closed fast.
Okay, but with that kind of speed, 150 cases a day, My mind immediately goes to the nightmare scenario. How do you track identity in a furnace?
You can't use paper, can't use plastic, everything melts. The chain of custody relies on a little stainless steel ID disc.
A physical coin?
Basically, it has a number stamped on it that matches all the paperwork. That disc goes into the retort with the body. It survives the 2,000-degree heat, and it comes out with the ashes. It's the unforgeable link.
Huh, low tech, but it works.
Sometimes the simplest solution is the best.
Now, we talked about smoke being forbidden, but there are invisible things coming out of that stack that are even worse. Let's talk about mercury.
This is the industry's silent crisis. It comes from dental amalgam fillings. When you heat those up, the mercury vaporizes, and it's a potent neurotoxin.
So how do you even catch a vapor?
You have to essentially freeze it out. The exhaust gas, which is at 1,600 degrees, is rapidly cooled down to about 320 degrees.
That's a massive temperature drop.
They use heat exchangers. Then, once it's cool, they inject activated carbon. The carbon binds to the mercury. Then the whole stream goes through a baghouse, giant fabric filters that catch the carbon particles with the mercury attached.
So the mercury ends up trapped in a filter, not in the atmosphere.
Correct. But think about the energy we just described. Heat it up to 1,600 degrees, then cool it down to 300. It's an enormous amount of energy manipulation.
And that leads us to maybe the most surprising part of this for me, the energy alchemy. Because the body isn't just a passenger, it's fuel.
It is grim, but it's structurally true. It's called autogenous combustion. Once the soft tissue really ignites, it releases a huge amount of thermal energy.
And the computer sees that.
The sensors detect the temperature spike, and the PLC actually cuts the gas supply to the burners. For the middle 30 minutes of the cycle, the body is sustaining its own combustion. It saves fuel, reduces the carbon footprint.
But we're still just venting a ton of heat into the sky, aren't we? The note said 70 to 80 kilowatt hours per cremation.
Historically, yes, just waste heat. But the aha moment for modern engineering is recovery. Why throw that energy away?
And this is where we get to the swimming pools.
It sounds like an urban legend, but it is 100% real. There are facilities, like the Skipton Crematorium in the UK, that use thermal energy recovery units.
They just capture the exhaust heat.
They run the hot exhaust through a boiler. That hot water then gets piped into district heating networks. So yes, literally, the heat from the crematorium is being used to warm local schools, housing, and public swimming pools.
I have to ask, how does the public react to that? I mean, Grandma is heating the radiator.
It's polarized. Some people find it deeply unsettling. Others see it as a final act of community service. Thermally, it just makes perfect sense.
And there are even systems making electricity from this, right?
The organic Rankine cycle. It can turn that waste heat into about 50 kilowatts of power, enough to power the lights, fans, and computers of the crematorium itself. It's almost a closed loop.
Looking at all this, it feels like gas is the standard now, but maybe not for long. Are we moving away from fire?
We are. The trend is toward carbon neutrality. You're seeing the rise of electric retorts, especially in Europe. They use high-resistance coils, like a giant toaster, instead of a flame.
So no fossil fuels.
Zero. But the bigger shift, I think, might be to water.
Alkaline hydrolysis.
Or aquamation. It's the radical alternative. You use water, an alkali solution, and heat. And it mimics natural decomposition just much, much faster.
And the energy use.
It uses 1/8 the energy of flame cremation. No mercury emissions, no smoke, no chimney. You can put one of these in a storefront.
That seems to be where the industrialization ultimately leads. Maximum efficiency, minimum footprint.
Exactly. We've optimized the chemistry, the thermodynamics, the throughput.
But looking at the whole picture, the autoloaders, the barcodes, the heat recovery, it does leave you with a question.
It's the core tension of the entire industry. We have achieved these incredible engineering triumphs. I mean, a 70-minute cycle is a marvel. But the question is, how do you maintain human dignity in a system that looks more and more like manufacturing?
When you're processing 150 cases a day.
Exactly. When the machine sees fuel and time, and the spreadsheet sees throughput, it is very, very hard to keep the person in the process. The challenge for the future isn't making the oven hotter or faster. It's ensuring that in the midst of all this industrial efficiency, we don't lose the reverence of the goodbye.
That is a heavy thought to end on, but a necessary one. It is just amazing to think about how much engineering goes into that final moment.
It really is the invisible infrastructure of our own mortality.
Thanks for listening to The Deep Dive. We will catch you on the next one.
DFS Memorials, affordable cremations, nationwide.